Hi, this is Scott Middle from Insaco. I wanted to talk a little bit about zirconia. Zirconia is a very interesting material for a variety of reasons. There's a lot of misconceptions with regards to the material, mostly with regards to its naming. I can give you long acronyms. We can say there is a YTZP PSZ. What does that mean? PSZ is the term for partially stabilized zirconia. YTZP is Yttria tetragonal zirconia polycrystal. I know it's a mouthful, but what happens is the yttria and/or, in another instance, magnesia, you could also add calcia, they are a stabilizing agent. And what that does is it allows for the material to phase transform in order to prevent the propagation of cracks through the material. What does that mean? What that means is the material has a very high toughness, and it is much higher in toughness than any other ceramic material out there. So a great example is you will see golf putters as well as golf drivers made of Yttria tetragonal zirconia polycrystal. This is because these materials can accommodate such a high amount of fracture toughness. In terms of the zirconias, it's a very small grain size material, so we can get very good surface roughnesses, typically under 1 microinch roughness average. There's a lot of different examples here in front of me. These are just representative of some of the things that we've done over the years. But you can see we've done parts for left ventricle assist devices. We've done parts for in-body applications. We've done parts for industrial applications. The one little feature of zirconia, which is sometimes almost terrifying, is with this phase transformation sometimes comes a volume expansion, particularly if the material is put under high heat or high stress. Consequently, when we see an application for zirconia with high heat or high stress, we have a tendency to be very nervous about even suggesting zirconia, because that volume expansion can result in the part getting bigger, which can be a problem if we're working to very tight tolerances. So again, the breadth of our capability, much like any other material, we can do just about any geometric feature that you could imagine. It's just a question of we're only limited by your design.
Are there size limitations for zirconia producers?
Yes, there are. There are a number of different material manufacturers who make zirconia, and it's limited by the size of their presses and the size of their furnaces. From Insaco's perspective, what I could say is we can machine parts up to 20 inches in diameter and up to 1 meter long. That is much greater than the size capability of anybody being able to fire these materials.
What's the typical surface roughness that you can achieve?
The typical surface roughness, I get that question a lot, and what happens is surface roughness is at the level that we're talking, at the level that we have the capability of doing, we are always limited by the material, not by our capability. What do I mean by that? What I mean is, a lot of times I use a snowball, and think of a snowball as it's ice crystals held together in a sea of water. Well, zirconia is zirconium oxide crystals held together in a sea of silica. What happens is we get a grain size of the material, and that grain size will control our surface roughness. So I can't make a part to a 1 microinch grain size if the grains are 10 microinches. But in the instance of zirconia, zirconia is a very small grain size material, so we can typically achieve under 1 microinch finish. So we can use zirconia successfully in a lot of left ventricle assist device application and other in-body applications. As a matter of fact, from an orthopedic perspective, when you see the balls that are used for hips, a lot of times they're either zirconia toughened alumina, they're alumina, or they're zirconia. But the surface roughness that can be achieved is controlled almost exclusively by the grain size of the material, and the grain size of the material in the case of zirconia is very small.